Good morning all. Welcome back to next lecture. In the last lecture, we discussed the concept of Cartesian coordinate system and the procedures to draw the graph from the given input-output table. I hope it was clear to you. Today, we will discuss the topic of graph of a linear function and the concept of slope. In the last week, we have also defined a function. We defined that, a function is a special kind of relation in which there is only one output for given input. A function can take different forms, namely, it's a linear function and non-linear functions. In this lecture, we will stick to the discussion of a linear function and the graphing of this particular linear function. A linear function is a first degree polynomial function of a one variable. And it is a function that changes at a constant rate with the respect to the independent variable. Thus, mathematically, a function f defined by y is equal to mx plus b, which is called a linear function, where the y is the dependent variable and x is the independent variable. And m here, it is the slope, that is constant rate of change, and b is the y-intercept term. As we discussed in the previous lecture, the graph of an equation is drawing that represents all ordered pairs that are the solution of an equation. Similarly, the graph of a linear function is a drawing representing all ordered pairs that are the solution to the linear function. One of the special feature of the linear function or linear equation is that we will get a straight line. Once we go for plotting the linear function, then we will get a straight line on the Cartesian coordinate system. So that is the most important, what we can say, that special feature of this particular function. Now, suppose we want to graph a linear function, that is y is equal to 2x minus 1. This is a linear function. The highest power of the variable x is equal to 1. We can begin by substituting the value of x into the equation, and accordingly we can determine the resulting value of y. Here, each pairs of x, we will have a y value. So we will have an ordered pair for the x and y values. So for example, if we have going to assume x is equal to minus 3, then it will be 2 into minus 3 minus 1, which is equal to minus 7. Similarly, if x is equal to 2, then it is 2 into minus 2 minus 1, which is equal to minus 5. If we are assuming x is equal to minus 1, then substitute x is equal to minus 1 on the above equation, then it is equal to minus 3. If it is 0, then it is minus 1. If it is 1, then y also equal to 1. When it is 2, then it is 2 into 2 minus 1, which is equal to 3. And when it is 3, then y value is equal to 5. So for each and every value of x, we have a corresponding value for the y. By joining these 2 points, or by taking the pairs, that is x and y values, we have for the minus 3, we have a minus 7. For minus 2, we have a minus 5. For minus 1, we have a minus 3 as well. So accordingly, we have a different points are here, and these are the known as coordinate points. Now, if we are going for drawing the graph of this particular function, then we want to plot each of this particular point on the coordinate plate or Cartesian system. then connect them with a straight line. And the resulting graph should be a straight line. That is the most important thing. See here how it will be. See, we are given the Cartesian system, and see here we are assuming the x axis and y axis here. Then first we will go for taking the first point or first coordinate point, which is -3, -7. So here -3 on the x axis. See here it is -3, then -7 here. So I am denoting a particular point here. So this is -3, -7 point. Now the second plot, that is -2, -5. So it will be, see, it will be here, that is -2 and -5. Then similarly we have -1, -3, the point here, that is -1x and 3y. And 0, -1. When x value is equal to 0, then y is equal to -1. This is that particular point. Similarly 1 and 1 we are plotted here, and 2, 3 which is here, and finally we have 3 and 5. So these are the various points which we are actually plotted here. And after plotting this particular point in the coordinate system, we want to connect these points with a straight line. So if you go for connecting these points, then it will be look like this. See, we have a straight line from here left to right. So here this is an upward sloping curve, which we can say that a straightforward straight line with the slope of 2, which passing through y is equal to 0, -1. See, we can also find out the set of coordinates in the another way by taking the intercept terms. In this case, see, we are going to find out both x and y intercept terms. And these points, actually represents the line that crosses x and y axis. See, and they are generally referred to as x-intercept and y-intercept. So in the case of x-intercept, it is the point at which the curve hit the horizontal axis and calculated by, assuming the value of y is equal to 0. Similarly, we have a y-intercept term as well, that is vertical intercept term, at which, the curve hit the vertical axis and can found by assuming the value of x is equal to 0. Let us assume one example. See, x plus 2y is equal to 7. Now here, by assuming x is equal to 0, we can find out the y value. So it will be y-intercept term. See, when x is equal to 0, then we will get, see, x plus 2y is the given function. Then we are assuming x is equal to 0. So instead of x, we are putting 0 plus 2y, which is equal to 7. Now we can solve for y. See, 2y is equal to 7, and by dividing both sides with 2, then y is equal to 7 divided by 2, which is equal to 3.5. So when x is equal to 0, then y is equal to 3.5. This is the one of the coordinate. Then another one, see, assuming y is equal to 0, we will get x-intercept term. See, here x plus 2y is equal to 7, then putting y is equal to 0, then it will become x plus 20 is equal to 7. So this particular term will become 0, so x is equal to 7. So when y is equal to 0, then the value of x is equal to 7. So we have a 2 coordinate point here. So by using this coordinate point, we can plot these 2 points here. See, in fact, each linear equation in a 2 variable, it is an infinite number of solution whose graphs lies on the line. However, see, we only need to find out 2 solutions, just like either it is y-intercept and x-intercept term, because by using only 2 points which are necessary to determine a straight line. By connecting these 2 points, we can join or draw a particular straight line. See, we have a Cartesian system and we have an x and y axis as well. The first coordinate point which we are calculated here, when x is equal to 0, then y is 3.5. So here on when x is equal to 0, then the value of y is equal to 3.5. So this is the point here, 3.5. Then the second coordinate point, that is 7, 0, which when y is equal to 0, then x is equal to 7. So this is so we have an x-intercept term as well as y-intercept term. By joining these 2 points, we will get a particular straight line, and we can extend in some extent in this particular part also in the upper portion as well. We will get the graph of this given function, that is x plus 2y, which is equal to 7. So in this way also you can draw the graph of a linear function. Now we have one of the special case of a linear function. See, the equation y is equal to 2, which is in the form of constant, and it can be written as it is 0x plus y is equal to 2. That means here it is assuming 0 for x, so this term will become 0, then what is remaining? Y is equal to 2. And it can be considered as a linear equation in 2 variable where the coefficient of x is equal to 0. The solution of 0x plus y is equal to 2, see, by assuming different value for x, we will get the y value is equal to 2. Let us consider when x is equal to minus 2, y is equal to 2. When x is equal to minus 1, again y is equal to 2. When x is equal to 0, 2. When x is equal to 1, again it is 2. When x is equal to 2, it is again come out with it 2, because y is equal to 2, which is constant. So we will get a coordinate point here. See, minus 2, 2, minus 1, 2, then 0, 2, 1, 2 and 2, 2. Now we will go for drawing a particular line here. See, this is the Cartesian system, and when we are straight line in the horizontal axis, see, these points will be look like this. This is the minus 2, when x is equal to minus 2, y is equal to 2. When x is equal to minus 1, y is equal to 2. So we have a straight line here, which is horizontal curve. This is one of the special case. See, the value of y variable along with the curve never change, and it is constant. That is everywhere along the curve, the change in y is 0. So regardless of the value of the change in x, the value of the y is remain constant. So we have a horizontal curve which is having the slope always a 0 slope. Okay, now another special case, see, when x is equal to 2, then this is in the format of a constant again function, which is f of x is equal to c, and which we can written as, that is x plus 0 y is equal to 2. So if we are assuming 0 for y, again see, the x is equal to 2. So by assuming different value for y, that is minus 2, minus 1, 0, 1, 2, we are getting the same answer, that is x is equal to 2. So the solution of x plus 0y is equal to 2, and by assuming the various values of y, we are getting the value of x is equal to 2. So the points here, minus 2 to minus 1 to 0 to 1 to 2 and 2. So if you go for drawing the graph of this particular curve, see here, the graph is again, it will come just like a straight line with a vertical curve. And if the curve is vertical, then the value of x variable along with the curve never change, and it is a constant. That is everywhere along the curve, the change in x is 0. So it describes that, see, both x variable and y variable is actually unrelated each other, and the two variables are unrelated when change in one variable, for example the independent variable, has no effect upon the other variable, that is dependent variable. Or it put slightly different manner, see, the two variables are unrelated when the dependent variable is constant regardless of the value of independent variable. So if, as usual, you know, the y variable is the dependent here, it will become a dependent variable, the curve is an horizontal. If the dependent variable is x variable, then the curve will be a vertical line. Now we are going to introduce the concept of slope of a linear function. See, we have to consider a linear function here, y is equal to mx plus b, where x and y are the variable, where y is the dependent variable and x is the independent variable, but its geometrical implication y is equal to mx plus b is a little bit different from the normal constant. See, when the linear function is plotted on a graph, it possesses two features. One will be the slope, that is m. This slope, which we call the slope coefficient, and the second one, see, it is the extreme point of a straight line, and it will intersect y-axis in a particular graph. And this is algebraically captured by the term of b, which we are generally calling it is a y-intercept coefficient by assuming the x value is equal to 0. When assuming x is equal to 0, then y will become b, and this b is considered as an intercept term or y-intercept coefficient. Now see the slope. We are going to define the concept of slope. See, the slope of a line, see, it is a measure of its steepness or incline. In other words, we can also say that the slope provides the information about, see, how the dependent variable changes when the independent variable change by 1 unit. Graphically, we can say that the slope of the line is the amount by which y coordinate of the point on the line changes when x coordinate is increased by 1 unit. That means, see, a vertical variation of the line for a horizontal move. The vertical variation of a line for the horizontal move of one positive unit. So, in this context of linear function, that is y is equal to mx plus b, where m is considered as the slope, it represents, the rate at which the dependent variable y change concerning to the independent variable y. So, the slope of the function is one of the important concept in economics as well, especially in the mathematical economics. The slope is used as a mathematics is synonymous with the term the marginal concept, that is marginal utility, marginal revenue, marginal cost. These terms are very popular in economics. So each capture, that means this slope capture the marginal concept, that is how much rate of change in the one variable due to changing in the rate changing in the another variable. Now see here, a graph of hypothetical linear function is drawn here. We can find the slope of this particular curve between 2 points, for example this point and this point here, between these 2 points. See, by taking the ratio of the length of opposite and adjacent sides. Suppose we want to measure the slope of the line between 2 points, these 2 points here, then the slope of the line is the amount by which y coordinate, that is y coordinate of the point in the line changes when x coordinate point in the line changes by 1 unit. See, graphically it represents the vertical variation of the line for the horizontal move of one positive unit. So thus the slope indicate, the change in the one variable due to changes in the another variable, and we can also, the slope can also popularly termed as it is rise over run. And see in the graph, see it is here, this is the rise part, this is rise part and this is run part. The horizontal part is known as the run and vertical part is known as rise. See in this graph of the linear function, there is a intercept terms are given. Here this is also one intercept, this is another intercept. What do you mean by the intercept? See, the intercept of a graph actually refers to the value of coordinate when the curves cut that particular coordinate, which means as we have two coordinates, for example, we have the x and y coordinates, we have two intercept terms as well. The first one is x coordinate. See, this is the x coordinate, or we can say that it is an horizontal intercept, which is the point at which the curve hit the horizontal axis. This is at this particular point, and it indicates the value of x variable when the value of y variable is 0. Similarly, we have the second intercept term here, that is y-intercept term, or we can also say that it is a vertical intercept, which is the point at which the curve hit the vertical axis, and it shows the value of y when the x value is equal to 0. So we have two intercept terms, one x-intercept and y-intercept terms. Now see here, in order to find the slope of linear function, we can use m is equal to, which is showing the slope is equal to changes in the value of y divided by changes in the value of x, or we can say that it is delta y by delta x. Delta is denoting for change, or which is equal to, see, rising part divided by run part, or we can say that height divided by base. So a large positive value of m, that means if the slope is large positive value, then which means that the graph increases steeply as you move from left to right. Similarly, a small but at the same time it is a positive value of m, that is slope, means that the graph increases but not very steeply. Similarly, a large negative value of m, that is slope, which means that the graph drops steeply as you move from left to right. And a small negative value of slope means that the graph decreases but not very steeply. So these are the various possibilities. Now let's see the sign and magnitude of the slope of the line indicate, the line direction as well as steepness respectively. See, the absolute value of the slope is large if the slant of the line is severe and small if the slant of the line is gradual. But put in the other ways, see, a line with large positive slope rise faster than a line with a smaller positive value. So the sign of the slope, that is positive or negative, indicate the direction of the line. So a positive slope means the line rise as it moves from left to right. A negative slope means the line falling as it moves from left to right. Regarding the magnitude of the slope, regarding the absolute value indicate, a large absolute value of the slope indicate it is more steepness, and a smaller absolute value of the slope indicate a less steepness of the line. So I have given here a approximate graph or the straight line which may vary from a linear function. See, this is the particular graph, it's a straight line. See, its slope may be approximately it is 4. This b is equal to 4, showing that its slope is 4. See, the second line, its slope is almost around 2, approximately 2. If the curve is like this slope, see, it will be equal to 1, that is slope is equal to 1. It is a 45-degree line in this particular case, so its slope will become 1. And in this curve, see, the slope is equal to 1 by 4. If the line is downward sloping, then see, it will become, the slope is become minus 1 by 4. If it is so, then see here, the slope is minus 2. If high steepness, see, the slope is equal to minus 4. So this is the one way we can express that how the slope and the steepness of a particular straight line is showing. Now, the negative slope of the linear curve. See, the linear function, here we have a linear curve which is downward sloping. When the direction of the graph is decreasing as it moves from left to right, then the slope is negative. The slope formula which represent, see, the ratio of changing in the vertical direction. This is the ratio of changing in the vertical direction or rise part or change in y to the changing horizontal direction, that is run or changing x. However, if the graph direction is decreases, it moves from left to right. It means that the vertical change is negative and the horizontal change is positive. It shows that the direction is decreasing from left to right. The rise will be negative and run will be the positive. and accordingly, therefore, the slope would be negative when the direction of the graph decreases from left to right. The slope formula can be expressed here. See, it will be minus 1 into rise divided by run, or minus 1 into height divided by base, or minus 1 into changes in the y divided by changes in x, or minus 1 into delta y divided by delta x. So it will be minus sign will be come here. So this is regarding negative sloped linear curve. Now let us consider one example. Find the slope and y-intercept for the graph of the function. See here, the given linear function, that is y is equal to minus 2 by 3x minus 5. See the coefficient of, this is in the format of y is equal to mx plus b. See here, the coefficient of x is equal to minus 2 by 3, and which is nothing but it is the slope. So minus 2 by 3 is the slope of the given linear function. And the y-intercept term, that is if x is equal to 0, then this entire term will become 0, then y is equal to minus 5. So when x is equal to 0, y is equal to minus 5, and this is known as y-intercept term. So y-intercept term can be found out by assuming x is equal to 0, then what will be the value of y? So here y is equal to minus 5 by assuming x is equal to 0. This is termed as an intercept. So slope is equal to here minus 2 by 3, and the y-intercept term is equal to 0 minus 5. Consider another example. See, find the slope and y-intercept for the graph of the equation. For example, the linear function, that is 3x plus 2y is equal to 6. Here we must solve the given equation for y. See, 2y is equal to minus 3x plus 6. Then divide the both side of the equation by 2. It will become, see, y is equal to minus 3 by 2 x plus 6 divided by 2. Therefore, we can simplify it, y is equal to minus 3 by 2 x plus 3. So the equation now is in the slope intercept format, that is y is equal to mx plus b. This is in the format of mx plus b, where the coefficient of x, here it is minus 3 by 2. So minus 3 by 2 is the slope of the line. And at the same time, when x is equal to 0, then this entire term will become 0, y is equal to 3. So the y-intercept term is equal to 0, 3. So here the slope is equal to minus 3 by 2, and the y-intercept term is equal to 0 and 3. Consider another example. See, find the slope and y-intercept term for the graph of an equation, that is x plus y is equal to 6. Our given function is a linear function. The power is equal to 1. X plus y is equal to 6. So here we are isolating y by taking the minus x in the both, subtracting the minus 5 in the both side of the equation. So the plus x and minus x will be cancelled out. So it will be y, which is equal to 6 minus x. Then y is equal to, we can rearrange this particular equation, y is equal to minus x plus 6. So here the slope, that is coefficient of x, is equal to minus 1. So the slope is equal to minus 1, and the y-intercept term, by assuming x is equal to 0, then minus x will become 0, y is equal to 6. So y-intercept term is here is equal to 0 and 6. So slope of this x plus y is equal to 6 is minus 1, and the y-intercept term is equal to 0 and 6. So let me conclude here. In this lecture, we actually discussed how to draw the graph of a linear function and the concept of slope. I hope it is clear to you. And in the next lecture, we will discuss how to find a slope of a given function from its coordinate points, and how to find the equation of a straight line, and then conclude with the discussion regarding how to find the point at which two straight lines intersect each other. We will see in the next lecture. Thank you.